In this video, we are going to do 4 questions from the chapter areas related to circle, including one MCQ and one assertion reason-based question. So let's begin with the first. In the first question, it says radii of cone and a cylinder are equal. If their curved surface areas are also equal, then the ratio of slant height of the cone to the slant height of the cylinder is what we have to get. So what we know that first is cone, right? So curved surface area of cone is what? Curved surface area of cone is what? That's pi RL, which is equal to, as you can see, it is equal to the curved surface area of cylinder, and curved surface area of cylinder is 2 pi RH. Moreover, it is given that their radii are equal, right? Their base radii are equal. So that means their radius are same. So I can cancel this R. Further, you can see pi and pi also get cancelled. What we are required to find out is the ratio of slant height, which is L, is to the height of the cylinder, that is L over H. Or I may say, this is what we have to get. L is to H is the question. So that's very simple. If I transpose H to the left hand side, we'll get what? 2 over 1. So the required ratio is 2 is to 1. And that's option A is correct in this case. Now let's come to the next question. In the second question, he says the area of a circle that can be inscribed in a square of side 6 centimeter. So what you can see that the area of this circle that can be inscribed in a square, that means outside we have a square and inside a circle. Let me show you once again. This I took a square first, and then we are going to take a circle, and the circle is inscribed in the square. That means all the edges, I'll say that this circle is touching the boundary of the square. That's what it means, right? The area of a circle that can be inscribed in a square. So outside it is a square. So we have ABCDs as a square over here, and we have to find the area of this circle. But the side is given how much? 6 centimeter. So what you can figure out from here that this should be how much? How much should be this? This is the diameter of this circle, right? And can I say that this diameter should be equal to the edge, as you can see from here. The diameter should be equal to the edge. Let's may place it. Let's say it's over here only. And this is the diameter. So that means I can take this as the radius, and we got it that this is 6 centimeter. What we have to find out is the area of this circle, which is pi r square. Well, pi, as I can see, the answers are in terms of pi options. So I'll let pi be pi, and the radius, as you know, the diameter over here is 6 centimeters. So clearly radius is 3 centimeter. So this is replacing r with 3. So it's 3 square. 3 square is what? 9. So it's 9 pi centimeter square. That's option D is correct in this case. The next one, as we can see, it's an assertion reason based. What's the assertion? It says, if the wire of length 22 centimeter is bent in the shape of a circle, then the area of this circle formed is 40 centimeter square. So we need to verify it. Let's say I took a wire, right? This I took a wire and its length is how much? 22 centimeter. Now I'm going to modify this in the form of a circle, the same wire, right? And it's very clear that this since this wire is used in making this circle, so obviously its circumference, which is 2 pi r, right? Circumference should be 22 centimeter. And they are saying that the area of this circle is 40 centimeters square. So for that, let's figure out how to get the radius. I can see that this is circumference, and circumference is what? 2 pi r. So I can replace this c with 2 pi r. So 2 pi r is equal to 22. So pi 2 is there. Pi I'm replacing with 22 over 7. R is r, 22 is there. This 22 get cancelled. On transposing these numbers to the other side, it's coming r as 7 over 2 centimeter. No need to bring down in fraction, as we have to find the area. We got the radius here, and then we are going to verify what's the area. Area is what? Pi r square. Area of a circle, pi replaced by 22 over 7. R square is what? 7 over 2 into 7 over 2, right? So square, right? That's the reason. Now I can reduce this. 7, 7 get cancelled. 2 1 times, 2 11 times. And as for calculation, we are getting area is what? 77 over 2. It is how much? 38.5? Yeah, it should be 38.5 centimeter square. Now check here. They are saying 40 centimeter square. So assertion is not correct, right? Assertion we can figure out from here that it is not correct. According to us, the answer area comes out to be how much? 38 centimeter square. They are saying 40. So assertion is wrong. So if this is wrong, still we need to see the reason. Sometimes the options are like not the conventional one. It says the circumference of the circumference of the circle is equal to the length of the wire. That's very true. This is what the length of the wire, and that is equal to the circumference. So the assertion is wrong, right? This assertion is wrong, and the reason is correct. So we'll say that in general, when assertion is wrong, the option is D, but that depends upon the other options given over here. Coming to that. Now in this question, it says in the given figure, sectors of concentric circle of radii 7 centimeter and 3 centimeter are given. What we have to find out is the area of the shaded region. So this is what the area of the shaded region is what we have to get, right? Now it's very clear from the figure that from this whole shaded region, right? From this whole shaded region, if we remove the area of this portion, right? If I remove the area, let me show you once again. If I remove the area of this portion, right? From the whole shaded portion, from this whole, right? If I remove the area of this smaller sector, we should get the area of the shaded region. So what I'm doing, I'm taking the small radius. I mean, by that I mean to say the shorter radius as 3.5 centimeter and the outer radius as 7 centimeter. And as we have discussed that the required area should become as what? Area of the outer sector, and the formula is what? Theta over 360 pi r square. I'll use capital R, reason being I'm talking about the outer sector, minus area of the inner sector will be what? Theta over 360 pi r square. This time small r will be used over here. Now what I can see that this is common, right? You can see that we have this thing as common, that is theta over 360 into pi, right? So this is coming common. Let me show you one last time. I'll try to take it common. Yeah, this is pi and this is coming common, right? So if I take this as common, that means theta over 360 pi as common, what we are getting inside as capital R square minus small r square. This way we can reduce the working instead of placing the value. Theta is what? I can see that this is 30 degree. So this is 30 over 360 into pi, replacing with 22 over 7 into capital R is what? 7 square minus 3.5 square. What I can do is reducing this by 3 1 times 3 0 0 3 1 times 3 12 times. This can again be reduced to 11 times 2 6 times. So over here we got 11 over 6 into 7. Now here instead of finding the square, I'll go for the identity. A square minus b square is a plus b into a minus b. So a plus b is what? 10.5. That multiplied by a minus b. And what is a minus b? That is this minus this is 3.5. Right. Now, remaining part of the working I'll do here. This is 11 multiplied by 6 into 7. This is 10.5, which can be written as what? 105 over 10, and 3.5 is what? 7 over 2. Now I can see that we can reduce it further. This is 7 and 7 get cancelled. Next, this is divisible by 3. So I'll divide it by 5. 5 2 times, 5 21 times. This is divisible by 3 is 3 2 times and 3 7 times. So at the end we got 7 into 11, that is 77 over, this is 2 into 2 into 2, that is 8. This much centimeter square. Yeah, it's in centimeter. So we'll say that this is the answer for this question.